of k-means clustering algorithm. In this, first we need to find out the default k value, how many clusters you want to take. This will be fixed. First, there are objects, how many clusters you want to make, that your wish. I want to make 2 or 3 or 4. So that is your wish. Based on that, the clusters will be decided. This will not be changed later. So after deciding the number of clusters, so if we decided the number of clusters are like 3, then we should select the cluster heads, centroids. That means centroids. How many? 3 centroids. If k value is 3, it means we want to make 3 clusters. So we should select 3 centroids. Randomly, you can take any centroid. No, the centroids will be adjusted, will be uh, exactly at the center after number of iterations, after the training process. So here in k-means clustering algorithm, first select the k value that will decide the number of clusters you want to make. After that, select the number of centroids. Like if k value is 3, we should select 3 centroids. If k value is 4, 4 centroids we should select. So there is no proper method to select. Randomly you can select any centroid, no problem, because the centroids will be adjusted. For example, here all the data points are here and other data points are here. So we have selected the centroid 1 as here. Centroid 1, second one is here. Now, if we keep on rotating, if we keep on repeating the process iterations, now these centroids will be moved to this. Exactly the middle position they will come. No problem. Next, after, yes, after selecting the 3 centroids, because our k is equal to 3, next calculate the distance objects to centroids. Means if these two are the centroids, now calculate the distance between all the centroids. So these two are the centroids. Here, all these points and all these points to distance to this centroid and distance to this centroid. Now, if which object is near to that cluster, means this is C1 and this C2. Now calculate this point is belongs to C1 or C2. Just calculate the distance. This one is 10 centimeters. This two is 9 centimeters. So this object is belongs to C1. Like that, distribute all these points to C1 and C2. Their cluster names given C1 to C2. Next, group calculate the distances between objects to centroids. Next point is grouping based on minimal distance. So to which cluster? To which cluster the object is near, to that cluster it is belongs to. Okay, based on the distances we are grouping them. So here, as I said, C1, C2 are the two clusters. If the object is C1, then it belongs to cluster 1. If the object is near to C2, then it belongs to cluster 2. Next, after grouping all, after distributing all these data points, then find out the centroid, mean centroid. Here we'll calculate mean centroid. Understood? Means, for example, this is belongs to cluster 1, these all belongs to cluster 2. Calculate the mean of this, mean of this, mean of this. Okay, if the mean point and cluster head is same now, then we can stop. We can stop. Otherwise, if the cluster head is changing this position, cluster center is changed, the value is changed, we need to repeat the process. Repeat the process. Now we'll take an example. We'll look into that. For example, some linear numbers 1, 2, 3, 5, 6, 7, 8, and 12. Okay, 1, 2, 3, 4, 5, 6, 7. Totally 8 numbers. I want to group them. I want to group these numbers, right? Totally 8 numbers into two clusters. So my k value is 2. My k value is 2. So after selecting the k value, then select the centroid. So defaultly I'm selecting my 2k value now. So this is my cluster 1 and this is my cluster 2. Now I am dividing these numbers into two clusters based on the distances. So before that, what is the cluster 1 head and what is the cluster 2 head? Like centroid, cluster 1 centroid and cluster 2 centroid. This we can select randomly. Cluster 1 centroid and cluster 2 centroid, because k value is 2. So we want to make them into two clusters. We want to make them into two clusters. So select two default centroids. Select two default centroids. I'm selecting worst case. One is the this one. This one is the centroid one, and this one is the centroid two. These are the cluster heads or centroids. Now this is the cluster one, cluster two. Two clusters we are going to form. Now calculate the distances between all these points to the cluster head or centroid. First, calculate the distances between each and every point to the centroid. Means 1 to this one to this one. 1 to C1, 1 to C2 distance, 2 to C1 distance, 2 to C2 distance, 3 to C1 distance, 3 to C2 distance. Next, 5 to C1, 5 to C2, 6 to C1, 6 to C2. Like that, we are going to calculate the distances, and based on the distances, we are separating or grouping them into clusters. Based on the distances means to which cluster, to which cluster that number is nearest, less distance. To which cluster the number has less distance, that cluster it is belongs to. Now calculating this one, I am taking 1 minus cluster 1 C1. It is distance is 0. 1 minus C2. C2 cluster is 2. So 1 minus 2 is 1. Mod I am taking. So cluster 1 distance is 0. Cluster 2 distance is 1. From where? From 1. So obviously this 1 is belongs to cluster 1. Now take the second point 2. Now again calculate the distance. 2 minus 1, it is 1. 2 minus 2, it is 0. So 0 is very minimal than 1. So 2 belongs to cluster 2. Now take number 3. Take number 3. Calculate the distances. 3 minus 1, it is 2. 3 minus 2, it is 1. 3 minus 1, 1, it is 2. 3 minus 2, it is 1. So it is nearest to cluster 2. So 3 belongs to here. Same. 5 minus 1 and 5 minus 2. So then 5 belongs to this cluster. Same. 6 minus 1, 6 minus 2. This is very nearest. 7, 8, and 12. Just calculated the simple distance. Close. Close. So now initially we prepared clusters. This is a initial clusters but not optimal clusters. First we decided how many clusters we want to make. That is our k value. Now I have taken k value as 2. K value as 2. So I need to prepare two clusters. My two clusters centroids, center point, heads are 1 and 2. Randomly I have taken, no problem. You can take any number. After taking the cluster heads or centroids, calculate the distance between each object to each number to each cluster. Like this 12 to 1 cluster 1, 12 to cluster 2. Obviously 12 is near to this distance is 10 and the cluster 1 is 11. So 10 is very nearest. So 12 belongs to cluster 2. So this is the initial process of making them into clusters. Okay, then after deciding their clusters, now find out the cluster head. Now find out the cluster head. This is the first iteration, and for the second iteration, find out the cluster head. Again, C1, C2, 1 comma 2 we have taken randomly. That is not correct, right? Randomly you have taken. So now we'll decide cluster head. Now take the mean or average of the C1. C1 mean is obviously one object is there, only one, this mean. Here, mean of these all, average of these, like how many here? 7 elements are there in. So 12 plus 8, 20, 27, 27 plus 6, 33, 33 plus 8, 38, 40, 43, 43 by 7, 43 by 7, so it is almost 6.1. Now C2 head is 6.1. C2 head is 6.1. C1 head is 1. C2 head is 6.1. If C1 head is 1, previously it is 1, now updated is also 1. C2 previously cluster head is 2 and updated one is 6.1. If it is not changed now, we can break the loop. If the values are not changed now, we can break the loop because the cluster elements will not be changed. If the head is not changed now, cluster elements will not be changed. If the head is changed now, cluster elements will be changed. That's what. Okay. So until there are no change, until there is no change in the cluster head, we should keep on repeat. Okay. For iteration 1, cluster head is 1, cluster 2 is 2. For second iteration, the cluster head is changed. Cluster 1 is 1 only, but cluster 2 head has become 6.1. Now, again, this point, centroid will be decided. Yes. Now, calculate the distances. Based on the distances, group them into clusters. Now here, cluster objects will be changed. Obviously, 1 minus 1 belongs to here. 2 also belongs to here. Now, 3 minus 1, distance is 2. 3 minus 6.1. Here it is 2, here it is 3.2. So 3 belongs to here, next to 5. 5 belongs to obviously this cluster. 5, 6 belongs to here, 7 belongs to here, 8 and 12. Now we got, again we redistributed the clusters. That is the completion of second iteration. So after that, again calculate the mean of cluster head. So here 1 plus 2 plus 3 by 3, 6 by 3. So C1 cluster head is 2. Now C2 cluster head is 5 plus 6, 11 plus 7, 8 plus 8. This is 8 plus 8, 26, 26 plus 8 plus, sorry, 5 plus 6, 11, 7, 18, 26, 28, 38, 38 by total how many? 5 elements. It is 7.6. Cluster 2 is 7.6. Now, both the cluster heads are changed. So again, we need to repeat the process. Centroids are updated, so elements will be updated. So 1 minus 2, 1, 2 minus 2, 0, 3 minus 2, 1, next to 4 is not there, 5 is belongs to, 5 minus 2, distance is 3, 5 minus 7, 5 minus 7.6 is 2.6 is the distance. So here 5 minus 2, it is 3. So 5 belongs to here, 5, 6, 7, 8 and 12. All. So here the elements are not changed. Again, if we calculate the mean, 2 will get, and here 7.6 will get. This is the 7.6. This is not 7.6. Understood? So here 1, 2, 3, 5, 6, 7, 8, 12. These are the elements. I make them into two clusters. I make them into two clusters so that my k value is 2. I selected default clusters C1 and C2. Cluster 1 head is like centroid is 1. Cluster 2 centroid is 2. Now I calculated the distances between all the points to two clusters. All the points to two clusters, to which cluster it is maintaining less distance, that object belongs to the cluster. For example, one is a point, one is a point maintaining less distance with C1, so 1 is belongs to C1. Next 2 is belongs to C2. 3, 5, 6, 7, 8, 9, 12 all are belongs to C2 cluster just based on the distance. Next, so here in cluster 1 only one element, in cluster 2 7 elements are there. Again for the second iteration I have changed the cluster head just by taking the mean of the cluster elements. So C1 only one element is there, so one value cluster head is 1, but C2 it is 2, 3, 5, 6, 7, 8, 12 by 7. So cluster head become 6.1. 6.1. Now again cluster head is changed now. Again group them. Again distribute these all elements to the clusters. Now 1 minus 1. So 1, 2, 3 belongs to C1 and 5, 6, 7, 8, 12 belongs to cluster 2. Now again calculate the mean. Again calculate the mean. So here 1 plus 2 plus 3, 6 by 3. Cluster 1 is 2 and cluster 2 is 7.6. Cluster 2 is 7.6. Now again calculate the distances. Based on the distances distribute them. So 1, 2, 3 belongs to cluster 1. 5, 6, 7, 8, 7, 8, 12 belongs to cluster 2. So this is the final one, because now if we calculate the centroid, that will not be changed. Cluster elements also will not be changed after this. So in a 3 iterations we make them all the elements into two clusters. The cluster heads are 2 and 7.6. 2 and 7.6 are the cluster heads. Cluster elements are here 1, 2, 3 for cluster 1, 5, 6, 7, 8 and 12 all belongs to cluster 2. Cluster 1 and cluster 2. These are the final clusters for the given data set. We make it into two groups. So if you want to make three, that just go with the k value is 3. Take the k value is 3 and defaultly select C1, C2, C3 and select default cluster IDs and continue the process. Calculate the distances and continue the process. That is what. If it is a one dimensional data, only a single array I have taken. If it is two dimensional, same point to point distance calculation. So in this way we can make them, we can partition the data into how many clusters you want, that many we can do. That is a k-means clustering model. For example, if a new data point is there, new data point is like 20. 20 is there. So now he is there 20. So which cluster I do belongs to? So which cluster do? Then we'll calculate the distance. Cluster head is 2. One more cluster is 7.6. Just calculate it. 2 minus 20 it is 18 and 7.6 minus 20 it is almost 13. So 18 comma 13, 13 is very much minimal, so 20 will belongs to this cluster. If we got 4, if we got a number like 4, now which cluster it is belongs to? Just calculate the distance. 4 minus 2 it is 2. 7.6 minus 4 it will be 2.4 I think. So now 4 belongs to cluster 1. So in this way we can arrange the new data points to clusters, just grouping the similar data items together based on the bifurcation. This is the k-means clustering algorithm. Yeah, any doubts in this? Logistic regression we have completed. K nearest neighbors and KNN we have completed. So if it is okay, we'll continue. the next boosting algorithm. Just one boosting algorithm in the session, in the schedule it is there. So after that we'll move on to the implementation part. So any doubts you can ask on these algorithms. So yesterday we have discussed ensemble learning methods, ensemble learning. In this, we are going to create new machine learning models, two or more machine learning models to handle big data, where we can't handle with the simple machine learning models. Simple machine learning models are like simple machine learning models are like uh, linear regression, logistic regression, KNN, SVM, decision tree. So these are the five simple machine learning models. If any data set we are not able to handle with this, for any data set, these models are getting overfitted, maximum underfitted. They're not able. Overfit means we have another solution. If they are getting underfitted, if these models are underfitted for any data set, then we need to increase the strength of these models. Increase the strength of these models. So how we can increase? By adding two or more models together. By adding two or more models together, we can increase the strength of the our model. So that adding is called ensemble learning. Ensemble learning. In this, we are going to add the basic machine learning models to handle, to provide a best fit model. Basic machine learning models, either two linear regressions, one logistic regression, one SVM, no problem. Or three SVMs, three decision trees, like that. Any number of models we can add, either homogeneously or heterogeneously. Means two same models we can add, two different models we can add. That is our wish. So based on the execution process, we have divided them into four ensemble learning models: bagging, boosting, stacking, bucket of models. Bagging and boosting will work on homogeneous learning. Stacking and bucket of models will be work on heterogeneous. First two, bagging and boosting, homogeneous models. It means same models we need to take. Same models we need to train. Either two logistic regression, two decision trees, okay, two KNNs, like same models we need to take in homogeneous, either in bagging or in boosting. In stacking and in bucket of models, we can combine any two, like one logistic regression, one decision tree, one SVM, or two SVMs, one decision tree, like that we can combine heterogeneously. Now, in homogeneous models, we'll select, and if they are executed parallelly, without depending on any others, without depending, each model is independently executing, parallel execution, then it is called bagging, parallel homogeneous process. Best example is random forest. Random forest can do both classification and regression. Random forest, parallel execution, and homogeneous combination. Next, sequential execution. If you are executing one after the other, homogeneous model, but they are executing sequentially. First model output is given to second model. Second model output is given to third model. third model output is given to fourth model. If you are executing like this dependently, then it is a sequential approach, homogeneous sequential, that is called a boosting models. These boosting models are three types, like ADA boost, G boost, and extreme gradient boosting. Extreme gradient boosting. And next, if you are selecting the models heterogeneously, then it is called stacking or a bucket of models. Same. If you are going with parallelly, it is a bucket of models. If you are going with sequentially, it is a stacking, like stack operation, push pop like that. It will be good. So there is no example for this. So we can combine any model in any format. So now we'll discuss about the boosting methodologies, how will be executed. So ADA boost, gradient boosting, and extreme gradient boost models are comes under boosting methods. So one example I will take from boosting. Yeah, here it is. These are the features x1, x2, x3, and x4, and so on. And target variable is y. x1, x2, x3, x4, and features, and target variable is y. So we trained a model 1. We trained a model, first model, and it is a boosting means homogeneous, so same model we need to take, like linear regression. If you are taking linear regression if you took, so first model, here we trained, so x values we are using, and we are forming an equation, y predicted is equal to w naught plus w1 x1 w2 x2 like this. So after calculating the y predicted value, we'll calculate y minus y predicted and actual value minus predicted value. So it will be the error. Y minus y predicted will be the error. Understood? So up to here, process is same. Up to here, same process. So whatever the error we got, we left that one. That is the final error for that given model. That will do in that case, in the simple linear regression model. But now in boosting methodology, we are going to train the linear regression again, same features we are taking, like x1, same features, same y predicted is equal to w naught plus w1 x1 plus w2 x2, and so on. Same features will take. This time we are not taking the original y value. Instead of that, our target variable is error at previous iteration. Error at previous iteration, that will be considered as a y predicted value. Now again, this y value is error. Here we'll get the y predicted value. Now again we'll get some error, that will be the target value for the next iteration. So it will be repeated until we get less error, and where the error is not possible to reduce, until then we keep on continuing the process. So here complete data set will be used sequentially. One model will be executed first. Whatever the error we got at model 1, that will be taken as a target variable for the next model. So that is the uh, boosting methodology. So here also, uh, data simple model we have taken, and for example a decision tree we have created. Okay, and this is decision tree error, whatever the error we got, that is passed to the next level. With that error, with that classes, we are passing, or we are building the next decision tree or next. So here, this is the base model. Always the base model will have the highest weightage. That is the, so final output will be, for example, we have built a first model 1 and model 2, and so for example model 3, and 3 decision trees, and we are going to predict model 1, model 2, model 3. This is not there. So what will be the final output for this? In this case we finally will get the weights. That final weights will be the actual weights of the equation. So in classification task, this is the example. So what is the output here? What is the output of this model? And what is the output as third model? So we are assigning some weightage. First model weightage, second model weightage, and third model weightage. For example, here we got 1, here we got 0, here we got 0. So if you are just counting, majority is 0, but if you are calculating with the uh, weightage, this is 70% weightage it will occupy, and it will occupy, for example, 20. For example, it is 10% weightage. Now final output will be 1. As usually, if you are not taken any weights, the majority is 0, so final output will be 0. But in boosting case, first model weightage, second model weightage, third model weightage. So we are combining that, multiplying the output with that, and we are deciding the final answer. So here 7 into 1 means 70 ones are there, only 30 zeros, 70 ones and 30 zeros. So output will be 1. That is the majority class. In that way, by applying a weights. One example is there for regression. This is the uh, years and salary that we are taking as X and Y. Finally, this is a Adabus method. Adabus method. The mean of this we have taken. Mean of this is this one. Mean of this is this one. 134, 134, 134, 134. Then we are subtracting from y minus f0. Y minus f0 we have taken. Now we'll calculate the f0. Y minus f0 we have calculated. This will be our target variable. Now this is not x values, and y minus f naught will be taken, and again we'll calculate the errors. Then we'll find out the f1 values. This is a boosting method. This XGBoost or AdaBoost or any boosting algorithm can do both regression as well as for classification they will do. You can ask me any doubts on this. So if it is okay, then we'll move on to the implementation phase.
Hope everything fine, sir. So I think we can move forward.
Now we'll implement all the models which we have discussed. So is my screen is visible?
Yes, sir. Yes, sir. Your screen is visible.
Okay. Just same data set, other we'll check for another data set. So breast cancer data set is not there, so I'll check it. Otherwise, we'll go with the fetal health, a classification problem that I will upload. So new data set I am taking, fetal health prediction. As usually, importing the data set with pandas. So for that, import the library pandas as PD. Take the data into a variable called d, pd dot read underscore csv, because it is a csv file. Next, take the path of the new data set, execute it. Now, this is a fetal health data set. Now I'll find out the null values. So all the values are same. Next, I will find out the target variables. Here are the columns like baseline value, accelerator, fetal moment, some of the options, some of the histogram width, histogram min max, and finally this is a fetal health. This is our target variable. So I'm taking this as a y. Take it into y. Y is equal to d of fetal health. If e. So I found 1 and 2. Maybe how many classes are there? We'll find out. Drop off. We'll get all the values into X. So 21 features are there. Target variable is 1. So 22 columns are there in the data set. Now I will apply logistic regression or logistic regression I will apply here. X values, Y values I have taken. So before going to apply, I will divide the data into train and test. That is with sklearn dot train underscore test underscore split. Now I'm finding X train, X test, Y train, Y test. X values and Y values. Test size is 0.25 and random underscore state is 20. Now we'll check the shape of all. X train dot shape dot shape, Y train dot shape and Y test dot shape. So finally the divided output, splitted output is properly arranged. All the shapes are correct. X train, X test, Y train, Y test. Now I'm going to train a logistic regression model. So from sklearn dot linear model there, linear underscore model, import logistic regression and linear regression. So creating an object LR that is for logistic regression. This is logistic regression model LR dot fit X train data and Y train data. Number of iterations are reached. No problem. We'll find out the y predicted value. L or m dot predict. X test data will get y predicted values. Now we'll find out the accuracy and classification report. Import classification report. Accuracy underscore of y predicted, comma, y test data. 83% accuracy we got, print. Classification report between y predicted, comma, y test. So here we can clearly observe at the class 2, the number of samples, and class 3 number of samples are very less. So we can easily say that the model is getting overfitted. Though it has a 83% accuracy, the model is getting overfitted due to the, we can say the reason, due to the not a bias, due to the variance. Bias is good because of accuracy is good, 83% overall accuracy, means model is capable to handle. Model is logistic regression model is capable to handle that given data set. But in the classification report, we can say that class 1 data is almost majority than the class 2 and class 3 data. So here we can clearly observe class 2, class 3 are dominated by class 1. So we can say that there is a variance in the data. The data is not correctly distributed, and indirectly we can say that imbalanced data. Due to that, it is getting overfitted. Okay. So we'll see the overfitting methodologies in next. How to avoid overfitting or how to avoid variance methods. So this is the basic logistic regression model using sklearn. First, take reading the data through pandas and taking the target variable. First, the initial process is checking for null values and counting the null values. If there is no null values, fill the null values with the mean or any approach. And after filling the null values, split the data into training and testing. Then after getting the train data and test data, y train and y test data, just go with select a model, which model you want to train. Here I selected a logistic regression and train that model with logistic regression. Object is LR, and through that model I have selected trained model is LRM. Through that we predicted y predicted values through x test values. Then calculated accuracy and uh, classification report. From the classification report, we observe that the model is getting overfitted. Now next, I will go with the k nearest neighbor model on same classification. So from sklearn dot, it is in nearest neighbors. It is in neighbors method. Import k nearest neighbor classifier. So knn can do both regression and classification. That's why. So kn is my object, k nearest neighbor classification. Here we need to mention number of k values we need to check. Like here I'm giving 10k nearest neighbors. Means the k value we need to check. So I will train the model. Here only I will train the model. KNM model name is kn dot fit x train comma y train. Next I will find out y predicted values, knm dot predict. We'll get y predicted values. Now find out accuracy. Print yp comma y test. So all together we'll print at once. 87% we got. Here I will print classification report. Same here also, due to the imbalanced data, KNN is also getting overfitted. Now we'll find out which K value is better. Randomly I have given K is equal to 2, sorry, K is equal to 10. When K is equal to 10, I got the accuracy as 87. So I will take the K value for I in range of 1 comma 50 up to 50 values I will try. Instead of printing the accuracy, I will take them into list. So 50 accuracies will get almost. No changes. Just I will plot a graph between 1 to 50 to 50 accuracies. G is equal to so one more list will take no problem for range of 1 comma 50 G dot append of I. Just 1 to 50 I'm rotating. Now I will plot accuracy iteration wise. 50 iterations I have taken, 50 different K values I took. So for all these 50 iterations, I will plot the accuracy. So from okay, reversely we have taken G on x-axis, accuracy on y-axis. See, when the K value is increasing 1, 2, 3, 4, 5, 6, the accuracy is consistent. So for this data set, any K value will be suitable. K is equal to 1, 2, 3, 4, 5, 6, any K value, the accuracy is not changing. So that's what. Next, this is a K nearest neighbor classification. We can do also KNN regression. As today we discussed logistic regression, K nearest neighbors, and clustering algorithm. Yes. So now we'll see KNN regression model. For KNN regression, we'll take the regression data, that is California house price prediction. This is the California house price prediction data. Now finding the target variable y is equal to d of made in house value no it is dd made in house value. Next, x is equal to d. Yeah, x values, y values we got. Now we'll find out x train and y train. It will be updated. X train, x test, y train, y test is equal to train test. This library is already imported. That's why I'm not taking xy and test underscore size 2 comma random underscore state, that will take any number. Now x test data, y test, x train, y train data is splitted. Now we'll import the lab k nearest neighbor regression. K nearest neighbor regression model. K nearest neighbor regression. Here also we need to mention the number of nearest neighbors we need to take. Now KNR model is equal to KNR dot fit x train find out the y predictor value KN x dash data. Now this is a regression model. So regression model, so we need to calculate error. Mean absolute error will calculate. Print predicted comma y test. So this is a mean absolute error with k nearest neighbor where k value is 10. So we can change the k value as 20 like this. 77,000 almost we got when k is equal to 10. So when we are increasing k value, the mean absolute error is decreasing. So we'll try different k values. We'll plot a graph. Error is a list for I in. So 100 k values I'm trying. For all k is equal to 1, 2, 3, 4, 5, 6, up to 100, the way k value will be constant. Next. Just appending iterations. Next. Plot gg comma error. So 1 to 100, which k value is providing less error? Just we are checking by using, uh, we are plotting the graph. For k is equal to 1, what is the error? K is equal to 2, what will be the error? K is equal to 3, what will be the error? Like that. So here we can clearly observe when k is equal to 1, the error is almost 95,000. K's value is increasing. K 1, 2, 3, 4, 5, 6. I think up to I have where 18 or 17, the K value is very minimal. And when we are increasing the K value, the error is increasing. So here for these, the best K value is 17 or 18. For this model, the best K value is 17 or 18. We'll go with from 10 to 50. Then we can clearly understand. Yeah, at 15, the error is very less, 76, under this 76,000. But when we are increasing the K value, the error is increasing. So for this data set, house price prediction, the best K value is 50. So this is a K nearest neighbor regression model. Logistic regression we have completed and K nearest neighbors regression and classification we have completed. Now we'll see one clustering model. For that, we'll take the X values only, not Y. These X values only will take to make them into clusters. So clustering sklearn dot cluster import k means clustering. Again k means clustering. Here we need to mention the number of clusters, how many clusters you want to take, you want to make. So I want to make initially the 5 clusters, and my model is So km dot fit only X data. Yes. So this is already made it into 5 clusters. Now we'll see what are these 5 clusters. Dot cluster centers. What are the cluster heads? Cluster center means now dot cluster. Cluster centers only we can print. cluster values. Now only cluster centers we can print. This is cluster 1 center, cluster 2 center, cluster 3 center, cluster 4 and cluster 5. Cluster 5 heads. For when we have taken 5 clusters, so 5 head points it has given. So if we are going to take 10 clusters, then it will give 10 cluster heads. These are the 10 clustering heads it is prepared. So is we have cluster label or any option, print labels, cluster labels. Yeah, cluster label 4, 5, 7, 0, 2, 9. They are the cluster labels. 5 clusters, 10 cluster labels. Yeah, 10 clusters. These are the cluster labels. Yeah, any doubts on this? You can ask. This is a k-means clustering execution process. Now, last one, I will show you the XGBoost also. Meanwhile, you can ask doubts. So a gradient boosting model I'm using. With that, finding the y predicted values, boost m dot predict. Just try and find out the accuracy and classification report for fetal health prediction. So we got 94, but we'll see the classification report. So here also almost it is boosted. See, with the boosting methodology, I said we can handle the variance problems with ensemble learning. So here class imbalance is overcome with the boosting methodology. Yes, you can observe with the logistic regression accuracy, we got 83% accuracy, and the precision of class 1 is 96, class 2 is 0.38, class 3 is 0.68, and when recall also no, there is a huge difference. Even F1 score also there is a huge difference between uh, class 1 to class 2 class 3 but here for xg boost it's a gradient boosting. Perhaps the precision is precision for class 1 is 0.99 and class 3 is 0.94. Just little bit change in class 2. But recall and F1 score almost managed, though it has imbalanced classes. The data is imbalanced classes, but it is overcome. That is the use of best advantage in boosting algorithms and ensemble learning algorithms. Yeah, if you have any doubts, you can ask. All models I have implemented. You can use chat also to ask any doubts. So this today I have discussed just how logistic regression will work, how k nearest neighbors will work, how k means clustering will work, and extreme gradient boosting methodology how they will work. So all these four models I have implemented in this implementation part. If you have any doubts, you can ask me.
Ramesh sir,
Sir,
still is there any content you want to deliver?
no sir, no content.
Okay, just waiting for the participants' questions, right?
Yes, yes, sir. Question answer.
Okay.
You can use chat box also to answer to